Welcome back. For our introduction to this lesson, I have kind of a little game for you. This kind of goes along with the game that we like to play on our cell phones and iPads and iPods and things called 4 Picks, 1 Word. Except it's not really one word, it's what do these 4 pictures have in common? I'll let you think about that for a minute or two here, just a few seconds. What could these 4 things have in common? A sheep, this is called a gray-cheeked parrot, angleworms that you use to catch fish, and an American toad. I was a little surprised by this. Maybe you will be too, or maybe you'll find this interesting. All 4 of these animals have the same life expectancy. Each one of these animals, their expected life expectancy is 15 years. I was a little bit surprised that a toad or a worm would live 15 years. I was not so surprised by the sheep or the parrot, but I found that interesting. So that leads us right into what we're going to do today. Here's an example of a problem we will do. Number of years of various types of animals expected to live are listed in a data table, and we're going to be constructing histograms of data. So here we go. In order to construct a histogram, we need to know what that is. And before I tell you what that is, our objective for today is for you to be able to display and interpret data in a histogram. So what is a histogram? It is a type of a bar chart, and that bar chart displays only numerical data. And the numerical data is presented in equal intervals along the x-axis. There's no overlap in the intervals. And on the y-axis it always contains the frequency of occurrence. So let's jump right in and make some histograms. Here's our first problem. And here's the data table that's given to us of the running time in minutes of different movies. In this example, they already give us the intervals, but I also want to teach you how to find the intervals over here on the right if you are not given the intervals. So you need to be able to come up with that if you don't know how. And remember, we said these intervals have to have equal spacing, equal number of data points in each interval. So the way that you're going to do that, you're going to find your highest and your lowest data points in your table, and you're going to subtract those. We call that the range. Okay? We'll be working a little bit more with that in the future when we deal with some more statistics. The range in this example is 130, and then for our purposes we're only going to choose 5 bars or 6 bars for our histogram. In this example we've chosen 5 because there are 5 intervals that are given. And this range right here is a minimum range. We want the number to be actually bigger than that. So I want a number bigger than 130 that 5 will divide into evenly. So I round it up to 150, which gives us an interval size of 30. And if you actually subtract these intervals, that's what they use. They have an interval size of 30 for each of those. Alright, so that's the toughest part of making a histogram, is finding those intervals. Once you have your intervals, do your frequency table, which we've talked about in the past, using your tally marks and then writing your frequency. And then from there, all we need to do is actually go ahead and construct our frequency table, or excuse me, our histogram. And let's see, I'll choose purple for this one. So the first interval, we have a frequency of 8. So I want my interval to go all the way up to 8 on that one, right about there. My second interval is also 8, so I'm going to choose that one to be the same height as the first one. Third interval only goes up to 3, so that one's going to go about maybe, I don't know, right about there. Remember, there are no gaps in our intervals. However, the next bar has a height of 0 or a frequency of 0, so that will appear like a gap. And then the last one has a frequency of 1, so that one's going to be real short. And try to make these about the same width as well. So there you go. There you have it. That is a histogram representing the data given to us in that data table. Here's a chance for you to try. Go ahead and pause the video. There is a data table of test scores. I want you to go ahead and make a frequency table first and then put that into a histogram with equal intervals. Please label your axes, and I'll show you what I came up with when you come back. All right, here's what I came up with for my intervals. Whoops, let me go back to that. All right, here's what I came up with. My highest was 100 minus the lowest is 73, giving us a 27 for our range. I chose 6 bars, so I rounded up to 30, which gives me an interval of 5. Okay, so back to our frequency table then. Here's the frequency table I came up with. Each of my intervals is 5 units wide. It contains my lowest value, which was, I believe, 73, and my highest value was 100. Okay, so it has all of those values contained in it. And then here is the histogram that I came up with as a result. I chose 6 bars, and it has each of those frequencies. Yours may be different, just depending on what you chose to round up to and how many bars you chose for your histogram. That doesn't make it any less correct. These can be represented in different ways. All right, the last thing we need to be able to do is analyze and interpret data that's given to us in a histogram. So here's a problem. It says how many Cincinnati Reds players were at bat? At least 400 times in 2006. Well, if we look at this table, at least 400 is the last 2 bars, and the second to the last bar looks like that is 5. So that would have been 5 players. And then the last bar goes up to 2. So if we add those 2 together, we get a total of 7 players were at bat at least, or excuse me, they were at bat at least 400 times in 2006. All right, the second problem asks us, what percent of the players were at bat 199 times or fewer? Well, I hope that you recall that the percent is equal to the part, whatever the part is, divided by the whole, and then times 100. Okay, we've worked with percents quite a bit this year, and that never changes. So we need to figure out what the part is, what the whole is, and then we can find our percent. Okay, so in this example, 199 times or fewer is going to be the last 2 bars, and it looks like the first bar here is at 17, and the second bar is at 4. So 17 plus 4 is 21. So that's our part. So to find the whole, then we need to add all the bars together. Well, we're already at 21 with the first 2 bars. It looks like this one only goes up to 1. So if we add 1 to 21, that gives us 22. This one we said was 5. 22 plus 5 is 27. Plus 2 more is 29. So then if we go ahead and divide that out, you can use a calculator, and you would take 21 divided by 29 and multiply it by 100, and that gives you, to the nearest whole percent, 72%. Comes out 72.4, but we're just going to call it 72%. And there you have it. Now you can do analysis and you can make histograms. See you next time.